Hello students, in this video we will solve some additional problems on inverse Z transform. First problem, evaluate inverse Z transform of 3Z divided by Z minus 1 into Z minus 2. The first step is to write inverse Z transform of 3z divided by z minus 1 into z minus 2 in the standard form so that you can easily obtain the inverse z transform. Consider 3z divided by z minus 1 into z minus 2 and split it so that inverse z transform of 3z divided by z minus 1 into z minus 2 becomes inverse z transform of a divided by z minus 1 plus b divided by z minus 2. But just recall the note in the previous video. If you have z minus k term in the denominator means multiply z to the numerator. Here z minus 1 is in the denominator, multiply z to the numerator. Similarly z minus 2 in the denominator, multiply z to the numerator. Therefore, inverse z transform of 3z divided by z minus 1 into z minus 2 is equal to inverse z transform of az divided by z minus 1 plus bz divided by z minus 2. But inverse z transform of z by z minus 1 is 1 and inverse z transform of z by z minus 2 is 2 power n. Therefore, inverse z transform of 3z divided by z minus 1 into z minus 2 is a into 1 plus b into 2 power n. Now, we have to find a and b values. To find a and b, consider 3z divided by z minus 1 into z minus 2 is equal to az divided by z minus 1 plus bz divided by z minus 2. Cancel z from both the sides so that you will get 3 divided by z minus 1 into z minus 2 which is equal to a divided by z minus 1 plus b divided by z minus 2. Now it will turn into a partial fraction method. Now we have to find a and b values. To get a, consider 3 divided by z minus 1 into z minus 2 equal to a divided by z minus 1. Just close the term z minus 1 on both the sides so that you will get a as 3 divided by z minus 2. Now substitute z is equal to 1. Therefore, a is equal to minus 3. Similarly, b is equal to 3 divided by z minus 1 and substitute z is equal to 2 so that b is equal to 3. By substituting a and b values, you will get inverse z transform of 3z divided by z minus 1 into z minus 2 equal to minus 3 plus 3 into 2 power n or 3 into 2 power n minus 1. Next problem. Evaluate inverse z transform of 5z divided by 2 minus z into 3z minus 1. Inverse z transform of 5z divided by 2 minus z into 3z minus 1 can be written as inverse z transform of az divided by 2 minus z plus bz divided by 3z minus 1. To make it standard form, take minus outside from the first term and 3 outside from the denominator of the second term, so that you will get inverse z transform of 5z divided by 2 minus z into 3z minus 1 as inverse z transform of minus a into z divided by z minus 2 plus b into z divided by 3 into z minus 1 by 3. But inverse z transform of z by z minus 2 is 2 power n, and inverse z transform of z divided by z minus 1 by 3 is 1 by 3 power n. Therefore, inverse z transform of 5z divided by 2 minus z into 3z minus 1 is minus a into 2 power n plus b by 3 into 1 by 3 whole raised to n. Now you have to find a and b values. To find a and b, consider 5z divided by 2 minus z into 3z minus 1, which is equal to az divided by 2 minus z plus bz divided by 3z minus 1. Cancel z on both the sides, so that you will get 5 divided by 2 minus z into 3z minus 1, which is equal to a divided by 2 minus z plus b divided by 3z minus 1, which implies a is equal to 5 divided by 3z minus 1. Now substitute z is equal to 2. Therefore, a is equal to 1. Similarly, b is equal to 5 divided by 2 minus z, and substitute z is equal to 1 by 3, so that you will get b, which is equal to 3. Now substitute a and b values. Therefore, inverse z transform of 5z divided by 2 minus z into 3z minus 1 is minus 1 into 2 power n plus 1 by 3 whole raised to n. Next problem. Find inverse z transform of 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4. In order to reduce it into a standard form of inverse z transform, we just factorize the denominator, so that we get inverse z transform of 4z square minus 2z divided by z minus 1 into z minus 2 whole square. And now by splitting, you will get inverse z transform of az divided by z minus 1 plus bz divided by z minus 2 plus c into 2z divided by z minus 2 whole square. And inverse z transform of z by z minus 1 is 1. Inverse z transform of z by z minus 2 is 2 power n, and inverse z transform of 2z divided by z minus 2 whole square is 2 power n into n. Therefore, inverse z transform of 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4 becomes a into 1 plus b into 2 power n plus c into 2 power n into n. To find ABC, let 4z minus 2 divided by z minus 1 into z minus 2 whole square, which is equal to a divided by z minus 1 plus b divided by z minus 2 plus 2c divided by z minus 2 whole square, which implies a is 4z minus 2 divided by z minus 2 whole square, and substitute z is equal to 1, so that you will get a is equal to 2. Similarly, c is equal to 4z minus 2 divided by 2 into z minus 1, and by substituting z is equal to 2, you will get c is equal to 3. Also, 4z minus 2 is equal to a into z minus 2 whole square plus b into z minus 1 into z minus 2 plus 2c into z minus 1. By comparing the coefficient of z square, we will get b is equal to minus 2. Now by substituting a, b and c, Inverse Z transform of 4z square minus 2z divided by z cube minus 5z square plus 8z minus 4 becomes 2 minus 2 into 2 power n plus 3 into 2 power n into n. Next one, evaluate inverse Z transform of 8z minus z cube divided by 4 minus z whole cube. Inverse Z transform of 8z minus z cube divided by 4 minus z whole cube can also be written as inverse Z transform of z cube minus 8z divided by z minus 4 whole cube, which can be split as inverse Z transform of a divided by z minus 4 plus b divided by z minus 4 whole square plus c divided by z minus 4 whole cube. Since z minus 4 in the denominator, so multiply z to the numerator. And in the second term, z minus 4 whole square in the denominator, so multiply 4z to the numerator. Similarly, z minus 4 whole cube in the denominator, so multiply 4z square plus 16z to the numerator. But inverse Z transform of z by z minus 4 is 4 power n. Inverse Z transform of 4z by z minus 4 whole square is 4 power n into n. And inverse Z transform of 4z square plus 16z divided by z minus 4 whole cube is 4 power n into n square. Therefore, inverse Z transform of 8z minus z cube divided by 4 minus z whole cube becomes a into 4 power n plus b into 4 power n into n plus c into 4 power n into n square. Now we have to find a, b and c values. Consider z cube minus 8z divided by z minus 4 whole cube, which is equal to az divided by z minus 4 plus b into 4z divided by z minus 4 whole square plus c into 4z square plus 16z divided by z minus 4 whole cube, which is also equal to z square minus 8 divided by z minus 4 whole cube equal to a divided by z minus 4 plus 4b divided by z minus 4 whole square plus c into 4z plus 16 divided by z minus 4 whole cube, which implies z square minus 8 is equal to a into z minus 4 whole square plus 4b into z minus 4 plus c into 4z plus 16. To find c, put z is equal to 4 so that we will get c equal to 1 by 4. To find a, compare the coefficient of z square and you will get a equal to 1. Similarly, to find b, put z is equal to 0 and the b value is 7 by 4. Now substitute a, b and c values so that you will get inverse Z transform of 8z minus z cube divided by 4 minus z whole cube equal to 4 power n plus 7 by 4 into 4 power n into n plus 1 by 4 into 4 power n into n square. Next problem. Find inverse Z transform of z cube minus 20z divided by z minus 2 whole cube into z minus 4. Inverse Z transform of z cube minus 20z divided by z minus 2 whole cube into z minus 4 can be written as inverse Z transform of az divided by z minus 2 plus b into 2z divided by z minus 2 whole square plus c into 2z square plus 4z divided by z minus 2 whole cube plus dz divided by z minus 4. And inverse Z transform of Z by Z minus 2 is 2 power n. Inverse Z transform of 2Z divided by Z minus 2 whole square is n into 2 power n. Inverse Z transform of 2Z square plus 4Z divided by Z minus 2 whole cube is n square into 2 power n. And inverse Z transform of Z by Z minus 4 is 4 power n. Therefore, inverse Z transform of Z cube minus 20Z divided by Z minus 2 whole cube into Z minus 4 is equal to A into 2 power n plus B into 2 power n into n plus C into 2 power n into n square plus D into 4 power n. Now you have to find A, B, C and D values. To find A, B, C and D, let Z square minus 20 divided by Z minus 2 whole cube into Z minus 4 is equal to A divided by Z minus 2 plus 2B divided by Z minus 2 whole square plus C into 2Z plus 4 divided by Z minus 2 whole cube plus D divided by Z minus 4, which implies D is equal to Z square minus 20 divided by Z minus 2 whole cube. Substitute Z is equal to 4 so that D is equal to minus 1 by 2 and C is equal to Z square minus 20 divided by Z minus 4 into 2Z plus 4. By substituting Z is equal to 2, you will get C is equal to 1. Also, Z square minus 20 is equal to A into Z minus 2 whole square into Z minus 4 plus 2B into Z minus 2 into Z minus 4 plus C into 2Z plus 4 into Z minus 4 plus D into Z minus 2 whole cube. To find A, compare coefficient of Z cube so that we will get A is equal to minus D, which is equal to 1 by 2. To find B, put Z is equal to 0 so that you will get B is equal to 0. By substituting A, B, C and D, we will get inverse Z transform of Z cube minus 20Z divided by Z minus 2 whole cube into Z minus 4 as 1 by 2 into 2 power n plus 2 power n into n square minus 4 power n into half. Next problem. Using Z transform, solve the difference equation un plus 2 plus 4 into un plus 1 plus 3 into un is equal to 3 power n with the initial condition u0 is equal to 0, u1 is equal to 1. The first step is to take the Z transform on both the sides. That is, Z transform of un plus 2 plus 4 times Z transform of un plus 1 plus 3 times Z transform of un is equal to Z transform of 3 power n. If Z transform of un is u, then Z transform of un plus 1 is Z into u minus Z into u0 and Z transform of un plus 2 is Z square into u minus Z square into u0 minus Z into u1. By substituting these and using the initial condition, you will get Z square into u minus Z plus 4Z into u plus 3 into u is equal to Z divided by Z minus 3. By taking u common, Z square plus 4Z plus 3 into u is equal to Z square minus 2Z divided by Z minus 3. Therefore, u is equal to Z square minus 2Z divided by Z minus 3 into Z plus 1 into Z plus 3. Now by splitting, u becomes az divided by z minus 3 plus bz divided by z plus 1 plus cz divided by z plus 3. By partial fraction method, you will get a equal to 1 by 24, b is equal to 3 by 8 and c is equal to minus 5 by 12. Therefore, the solution of the difference equation is obtained by taking the inverse Z transform and is given by un is equal to 1 by 24 into 3 power n plus 3 by 8 into minus 1 to the power n minus 5 by 12 into minus 3 to the power n. Next problem. Using Z transform, solve yn plus 2 minus 4 yn is equal to 2 power n with the initial condition y0 is equal to 0 and y1 is equal to 2. By taking Z transform and using the initial conditions, we get z square into y minus 2z minus 4 into y is equal to z divided by z minus 2, or z square minus 4 into y equal to 2z square minus 3z divided by z minus 2. Therefore, y is equal to 2z square minus 3z divided by z minus 2 whole square into z plus 2, which is equal to az divided by z minus 2 plus b into 2z divided by z minus 2 whole square plus c into z divided by z plus 2. By partial fraction method, the value of a is equal to 7 by 16, b is equal to 1 by 8 and c is equal to minus 7 by 16. By substituting a, b, c and by taking inverse Z transform, you will get the solution of the given difference equation yn, which is equal to 7 by 16 into 2 power n plus 1 by 8 into n into 2 power n minus 7 by 16 into minus 2 power n. Last problem. Using Z transform, solve the difference equation yn plus 2 into yn plus 1 plus yn is equal to n with the initial condition y0 is equal to y1 is equal to 0. Since Z transform of yn is equal to y implies Z transform of yn plus 1 is z into y minus z into y0, and Z transform of yn plus 2 is z square into y minus z square into y0 minus z into y1. By taking Z transform on both the sides of the difference equation and using the initial conditions, we get z square y plus 2 into z into y plus y is equal to z divided by z minus 1 whole square, or z square plus 2z plus 1 into y is equal to z divided by z minus 1 whole square. Therefore, y is equal to z divided by z plus 1 whole square into z minus 1 whole square, which is equal to az divided by z minus 1 plus bz divided by z minus 1 whole square plus cz divided by z plus 1 plus d into minus z divided by z plus 1 whole square. Now find the constants a, b, c and d. To find a, b, c and d, consider z divided by z plus 1 whole square into z minus 1 whole square, which is equal to az divided by z minus 1 plus bz divided by z minus 1 whole square plus cz divided by z plus 1 plus d into minus z divided by z plus 1 whole square, or 1 divided by z plus 1 whole square into z minus 1 whole square, which is equal to a divided by z minus 1 plus b divided by z minus 1 whole square plus c divided by z plus 1 minus d divided by z plus 1 whole square, which implies b is equal to 1 divided by z plus 1 whole square. By substituting z is equal to 1, we get b is equal to 1 by 4 and d is equal to minus 1 divided by z minus 1 whole square, and by substituting z is equal to minus 1, we get d is equal to minus 1 by 4. Also, 1 is equal to a into z minus 1 into z plus 1 whole square plus b into z plus 1 whole square plus c into z minus 1 whole square into z plus 1 minus d into z minus 1 whole square. By comparing the coefficient of z cube, you will get a plus c is equal to 0, and by substituting z is equal to 0, we get minus a plus c is equal to half. By solving these two equations, we get a is equal to minus 1 by 4 and c is equal to 1 by 4. Now by substituting a, b, c and d, we get y is equal to minus 1 by 4 into z divided by z minus 1 plus 1 by 4 into z divided by z minus 1 whole square plus 1 by 4 into z divided by z plus 1 minus 1 by 4 into minus z divided by z plus 1 whole square. But yn can be obtained by taking the inverse z transform, and inverse z transform of z by z minus 1 is 1. Inverse z transform of z by z minus 1 whole square is n, and inverse z transform of z by z plus 1 is minus 1 to the power n, and inverse z transform of minus z divided by z plus 1 whole square is minus 1 to the power n into n. Therefore, solution of the difference equation yn becomes minus 1 by 4 plus 1 by 4 into n plus 1 by 4 into minus 1 to the power n minus 1 by 4 into minus 1 to the power n into n, or yn is equal to 1 by 4 into n minus 1 into 1 minus 1 to the power n.